It's A-level mathematics, chapter 12, vectors. Now, I have a vector equation here of a line in 2 dimensions. So right now I'm only going to be dealing with 2 dimensions. So right here I have directions. So I have a direction going this way, direction this way, direction this way. So A is going to be here, P is here, P of t is actually going to be the slope at the what direction that is going. So it's going this way, and R is going to be of the equation that I have. So it's going to be from here to here. This is going to be my vertical, my up and down change where I start this piece right here, and this right here says the direction I'm going from wherever my starting point is. Alright, a line through point A in the direction of a non-zero vector P if R is any point on the line. The displacement vector AR is a multiple of P, so R is equal to OR equal to OA plus AR is equal to A plus T of P. So what that means is that right there is my directional vector, and here's where I'm starting. So think of it as y equals mx plus b. And this would be my y equals, and this is my mx, and this is my b. So this is basically like a starting point here, and this is going to be the direction that I'm going. (12.1.1) Finding a vector equation for the line through point 2, -1 with a gradient of 3/4 and deduce its Cartesian equation. So first thing, I need to take a look and understand what the position vector is. So position vector, it's kind of like my ordered pair like I have here, but it's written like this. Okay, it's going to be x on top of y right here. So there is no line between them though. So this is not a fraction. Okay, so for here, it's going to be x over y. So this one right here is going to be equal to 2 over -1, my x over y. Vector direction, so this is the direction I'm going, or kind of like my slope, is x over y, again to match this. But because x is my left and right, and my y is my up and down, I have to change this into run over rise. Because we normally, for my slope, it's rise over run. But in this case right here, because we have the vector, it's going to be x over y because it's got to match this that I have here. And so, since my gradient is 3/4, my run is going to be 4, and my rise is going to be 3. So my vector is going to look like that. So if I were to write my equation, I would get R equals 2, -1 plus T of 4, 3. Now I'm going to go through and show you how to turn this into the Cartesian equation. So let's start with this, and I know that these are my x's and these are my y's, so I'm going to rewrite that as x equals 2 plus t 4t, and y equals -1 plus 3t. So this is just multiplying by these right here. So there's my y value and my x values. Now I'm going to solve for the x value here. So I'm going to solve for, on this x value right here, I'm going to solve for the t here. And what that's going to do is actually going to get rid of this. So I'm going to plug this into my y equation, and I'm trying to get rid of my t here, so I could turn it into a Cartesian equation. So I'm going to have, let's take a look, x equals 2 plus 4t, subtract 2, x minus, so it's x minus 2 equals 4t. Divide both sides by 4. T is equal to x minus 2 over 4. So I'm going to replace what I have here. I'm going to replace that into here for this problem right here. So I'm going to make it into the y equals, because that's what my Cartesian equation is. So it's going to be y equals -1 plus 3 quantity. So this is where I'm going to plug in that. Now I'm going to plug it in, and I'm going to take this apart though. So this is going to be x over 4, and this is going to be -2 over 4. So I'm going to separate that. So it's going to be x over 4 minus This one right here is going to be reduced to 1/2. There we go. And that is all my t value. I just separated it to make my distribution a little bit easier. Y mine equals -1 plus 3 over 4x, and as I distribute over here I get minus 3 over 2. Okay, so if I need to combine that with that one, so this is going to be 2 over 2, so it's -2 over 2. So y equals 3 over 4x, and this becomes a minus. Like you said, that this is going to be -2 over 2, and I have to add it to 3 over 2. I get -5 over 2. So this is my Cartesian equation here, and this one right here is my vector equation. 12.1.2, find a vector equation for the line through point 3, 1, parallel to the y-axis, and deduce its Cartesian equation. Now this one should be really easy. So if it's parallel to the y-axis, I get m is equal to, so that's going to be a vertical, so it'd be 1 over 0. Because it's parallel to y-axis, that means it's going to have an undefined slope, and that is just going to be 1 over 0. Now, so I have this, okay, vector equation for this, so it's going to be r equals x over y, so it's going to be 3, 1 plus t, and this is going to be a quantity of, so right here, because it's supposed to be for my slope, I'm plugging in as x over y. It's going to be run over rise, so it's got a 0 run and a 1 rise right there. So there is my vector equation there, and we're going to deduce its Cartesian equation. So on the Cartesian equation, I'm going to get x equals 3 plus 0t. That's going to be important right there. Y equals, that's going to be 1 plus t. Now, because there's 0t here, that means I can't use x like I did on my past problem. I have to use y. So if I was to solve for t over here, I'll get t is equal to y minus 1. And so now that t is equal to y minus 1, I plug it in here. Anything times 0 gives me 0. So my Cartesian equation is going to be x equals 3. And if I remember this from algebra, this is actually a vertical line. X equals 3. There is no slope on this. I'm just going straight up and down on the x-axis. Now right here, find the points common to the pairs of lines. Now, since they are going to be common, I need to try and find a way to set them equal to each other. So what I'm going to do, I'm going to make this into a system of equations. So this right here, I get x is equal to 1 plus s. Y is equal to 2 plus s. Now for this one right here, I get x is equal to 3 plus t. And this one is y is equal to -2 plus 4t. Now I'm going to set these equal to each other here. So it's the x's go together, then the y's will go together. So I should get 1 plus s is equal to 3 plus t. Next one's going to be 2 plus s is equal to -2 plus 4t. Let's move the variables to the left side and my constants to the right. So if I look at this, this is going to become, let me see, this one, let's rewrite this one right here. So it's going to be a -t plus s is equal to, I'm moving this over here, 2. So now this one's going to be a -4t plus s is equal to, now subtract this over here, I get -4. So now I could work with this as a system of equations. So I have negative t plus s equals 2 and negative 4t plus s equals negative 4. Multiply this one here by a negative 1. So I should get t minus s equals negative 2. So let's do our math on this one right here. So I get negative 3t is equal to negative 6. Divide by negative 3, t is equal to a positive 2. So on this one right here, the points common for this is when t is negative 2. And since these are supposed to be common, I'm not going to have to solve for s, because t is going to be the points on this equation right here, and s is going to be the points common on, or I have that backwards. T is for the points common here, and s would be the points common here. So if I were to plug in, solve for s, I would end up getting the same thing in either point. But I'm going to go through and solve for s. So I know that t, so let's take a look right here. Okay, so now if I know that t is 2, so if I plug this in here into one of these here, so it'd be t is 2, so this is going to be 2 minus s equals negative 2. So subtract 2, I get negative s equals negative 4. So s is equal to positive 4. And I got that just by plugging this in. So I could pick any one of these that I want to do it, and here, I'll even show you here. So I have negative 2 plus s equals 2. Add 2 to both sides, or negative 2, so it's going to be plus s equals 2. So s is equal to 4. So either way, I still get s is equal to 4. So now, like I said, these are going to be common. So when I plug in t, it's going to give me the same points as I get here or here. Okay, so now all I have to do is plug into one of them. So let's go ahead and plug into one of them. So my x is equal to 3 plus, now t is 2, so it's going to be 2 times 1, it's going to give me 2, so I get x is 5. Y, right here, it gives me negative 2 plus same 2, so it's going to be 2 times 4 is 8. Y is 6. So now there's my x value, there's my y value, and I'm looking for a point. So my point here is going to be the ordered pair of 5, 6. Alright, for this next part right here, it says that lines with vector equations r equals a plus sp and r equals b plus tq have the same direction if p is a multiple of q. If, in addition, that b minus a is a multiple of q, and the lines are the same. Otherwise, the lines are parallel. So what that means is, right here, b minus a, multiple q, lines are going to be parallel, are the same. But otherwise, so if they have the same slope, so it's basically the same thing. Okay, if they have the same direction, they are going to be parallel. So that's the same thing as my Cartesian equation. If they have the same slope, they're parallel. And if they intersect at all the same points, then that means that they are going to be the same line. .1.4 show that the lines with vectors equations r equals 2i minus 3j plus s quantity of negative I plus 3j and r equals 4i plus t times quantity of 2i minus 6j are parallel, and find a vector equation for the parallel lines through .11. Now, there's another way of writing the equations. I know that x is my I, y is my j, and z is the k. So I could write it as this, so it's going to be ijk, so it could be written like this, and it also could be written up and down like what we have been doing in parentheses. So for this sake, let's take a look. Now this, my direction, is going to be x over y. It's my run over rise. So now this direction for s, it's going to be, this is going to be negative 1 over 3. And my t for this equation right here, it's going to be 2 over negative 6, like that. Now let's go ahead and let's turn these back into my gradient or my slope. So we're going to turn it back into that. So we know that these are going to be x over y, right? X over y. These are runs over rises. Run over rise. So let's twist it around. So this right here, my m is going to be, it's going to be negative 3 over 1, right? Negative 3 over 1, the negative goes up front. This one, my m is equal to negative 6 over 2, which reduces to negative 3 over 1. So now with this right here, I was able to prove that my slopes are going to be the same. So the slopes are going to be the same there. So let's take a look. These right here, these are different. So right here, lines with vector equations. Okay, parallel, find a vector equation for the parallel line through this. So now I have my slope. Okay, I have my gradient or my vector, my direction that I'm using. So either one of these will work because they're both the same thing. So for my equation, I'm going to have r is equal to, if it's through this point, it's going to be 1 over 1 plus t. I'm going to call it t because I feel like it. And I could use either one of these that I want because they're the same thing. They're just multiples of each other. So this one right here, I'm going to use a negative 1, 3. So on this one right here, that is my vector equation. So there it is in that form. Now I'm going to rewrite it in the ijk form. So if I were to rewrite this in ijk form, I would get r is equal to I plus j plus t quantity of negative I plus 3j. So there is my two different forms right here. So this is the form of ijk, and this is my standard vectors. Alright, practice and homework right here. So I wrote this down correctly. I kind of made a mistake last time I did, so apologize. Okay, this is down correctly. So if you still need to sit and stare at this, go ahead, pause the video.